So now that you understand a little bit about where the periodic table came from, I think it's important for us to take a look at how it's organized. This thing looks weird, but the organization of it is absolutely crucial to understand so that you can use it. It's probably the best tool we have in the chemistry lab. So let's take a look and see how it's organized. Now, there are some things about the table that we need to become familiar with, some ways of getting around. The first is that we don't call them rows or columns. We call the rows periods, hence the name periodic table, and that has to do with something called the periodic law, which we'll study later. We call the columns groups or families. And just like members of a group or family share something in common, the elements in a particular group or family share something in common. Since we arrange the elements by atomic number, we are also able to see patterns in their properties. And that allows us to group elements together in a more useful way. So taking a look at the common modern periodic table, this one is missing elements 110 through 118, but we don't know a lot about those elements yet. And so it's really not a big deal that those aren't there, because the most important parts of the periodic table are here. The first thing we want to understand is that this represents all of the chemical elements, substances that are made of one kind of atom. And we can loosely separate these into two general categories: metals and nonmetals. About 80% of all of the elements known are metals. They're all positioned over here on the left side of the table. The boundary is this staircase-shaped line just over here on the right. That's the boundary between the metals on the left and the nonmetals on the right. Now there's also a special group of elements along the stairs, right along that line, that are neither metals nor nonmetals. They're called semimetals or metalloids, and we'll talk about them later. Now, of the metals, we have this group in the middle. These elements, these metals, are called transition metals, and they are perhaps among the most interesting elements on the periodic table. Most of the elements, the way they're arranged, allow us to develop some rules to determine their behavior. The transition metals tend to break those rules. The other elements, the ones in the tall columns, are called main group elements. Sometimes they're called the standard elements, or sometimes they're called the representative elements. We'll call them main group elements. And those contain examples of every chemical and physical property that you can think of. They're found in those tall groups, those tall columns, the representative or main group elements. There are four groups, four families on the periodic table that I need you to be very aware of. They have special names because they're so commonly found in compounds. You'll notice that the groups on this particular table are numbered from 1 to 18 across the top of each of the groups. That's the modern way of numbering the families. There are other ways of doing it, and depending on the periodic table you look at, you might see the numbers 1 through 18. You usually will, but you might also see some Roman numerals 1, 2, 3, 4, 5, 6, 7, 8, and letters A and B that go with those. And that's the sort of old-fashioned way of numbering the families. We're going to focus on numbering them from 1 to 18. And the first family that you need to be aware of is over here, group number 1, the extreme left of the periodic table, not really including hydrogen, even though hydrogen appears to be there. Hydrogen kind of floats back and forth from one side to the other as needed by its properties. But I'm talking about these: lithium, sodium, potassium, rubidium, cesium, and francium. Those elements are called the alkali metals. And they are very reactive. The most reactive metals on the periodic table are the alkali metals. Immediately next to them in group 2, beryllium, magnesium, calcium, strontium, barium, and radium. Those are called the alkaline earth metals. And we find them, oddly enough, in biology quite a bit. Magnesium, calcium especially, are very important metals in biology. Barium and radium are used biologically, but they're not normally found in large amounts in living things. Now we're going to jump all the way over to the opposite side of the table, and we're going to look at these elements here: fluorine, chlorine, bromine, iodine. Those are called halogens. The word halogen comes from two words: halo, which means salt, and gen, which means maker. So the halogens are the salt makers, and we already know that common table salt contains one of them, chloride. Finally, we have group 18, helium, neon, argon, krypton, xenon, and radon. And those are called the noble gases. And they don't react. They're called noble because they don't mix with the common elements. They tend to be unreactive. Those are the four most common families, but there are other families that we're going to see elements in that are very reactive and that will form compounds that are fairly common. Finally, down here at the bottom, we have these two rows down here called the Lanthanide Series. That's numbers 57 through 70, and the actinides, numbers 89 through 102. Together, this whole group of two rows are called the inner transition metals, or the rare earth elements. And they are very odd elements by the way they behave. But what's important about them is the reason that they're separated like this. You'll notice that where they belong is between numbers 56 and 71, barium and lutetium, and numbers 88 and 103, radium and lawrencium. If we were to put them in there, then this table would be about twice as wide as it is right now. Some enterprising printer back in the 19th century or so decided that they could save money and paper by just putting those two below and showing by means of an arrow where they belong. So, you want to become familiar with the different terminology involved around the periodic table, being able to find things around the periodic table, knowing, for example, where the alkali metals are, the halogens, so that we can start to talk about these elements and their properties.